So let's look at an idea out of Unit 1. A major idea that's going to be a recurring theme this year, which is the domain of a function. So we're going to work on finding the domain. And we're going to do this using algebraic techniques. So I'm going to use algebra. So we're not really going to use any tables or graphs today. I'm just going to focus strictly on algebraic techniques. Okay, so let's look at a couple of examples here. I think I've got 4 in mind. So let's look at this first function. It's f of x equals the square root of 2x minus 6. Excellent. Now the definition of domain is all of the values that we're allowed to substitute in for x, which will give us a real number output. So basically when I'm figuring out the domain, I'm looking for actually the places where the function's undefined, because that's going to be, those are going to be the x values that I do not want to use. So in this case, since I'm dealing with the square root function, I know that I cannot evaluate the square root of a negative number and get a real number back. I can get a complex number back, but in terms of graphing here, and in terms of the way we think of domain and range, we're thinking about real values only. So I know that the whole inside of the square root function has to be greater than or equal to 0. So I'm going to set the inside greater than or equal to 0. I'm going to solve that inequality. I'll add 6 to both sides. I get 2x is greater than or equal to 6. I'll divide by 2. I get x is greater than or equal to 3. So that's my domain right there. Any x value I pick that's 3 or greater, if I plug it into the function, I will get a real number back. So I want to write that domain, x is greater than or equal to 3, in interval notation. So the way I can do that is the lowest value I can pick is 3. So I'm going to put a 3 with a square bracket, because that means I'm allowed to pick 3. The square bracket indicates the or equal to part. And it's any x value greater than or equal to 3, so I can go from 3 all the way up to infinity, parenthesis on the infinity. Because infinity, it isn't really a value that I can plug in, but when you say 3 comma infinity, you're basically saying you can pick any x value 3 or bigger, going on and on and on. So there's no upper limit to the x value that you can pick for the domain for this function. So there's my domain. So that trick works with most functions that have a square root in them. You just set the inside of the square root greater than or equal to 0, solve that out, and write your answer in interval notation. So let's look at another function here. How about g of x equals 7 over x squared minus 9. So in this case, I've got a rational function, and I know that, I can plug values in for x here, but the key to this one is that I'm not allowed to plug in a 3 here. Let's see what happens if I plug in 3. I did g of 3. I would get 7 over 3 squared minus 9. That equals 7 over 0. Well, 7 over 0 is undefined. That does not exist. The 0 with the slash through it stands for the empty set, stands for no solution, does not exist. So 3 would not be a number that is in my domain, because if I plug it in, I'm not getting a real number back. So a key to these type of problems is, let's see if we could factor that denominator. Factors 2x minus 3 times the point of the x plus 3. And now I'm looking for values of x that will make the denominator 0. Those are going to be the values that I'm not allowed to have in my domain. So here, x can't be 3. Here, x cannot be negative 3. So my domain in this case is going to be all numbers from negative infinity to infinity except 3 and negative 3. So the way I do that is in interval notation. I'm going to say my domain is negative infinity up to negative 3. Parenthesis on the negative 3. That means the negative 3 is not included in the domain. Union negative 3 to 3. So that means I can pick any number in between negative 3 and 3, but I cannot pick negative 3 and 3. That's what the parentheses indicate. Union 3 to infinity. So that right there, that's a fancy way of saying all x values are good except negative 3 and 3. Okay, let's keep going here. How about we'll look at the function h of x equals log base 2 of x plus 4. Okay, so you want to handle logarithmic functions almost the same way that you're handling square root functions in terms of finding the domain, because you cannot evaluate log functions for 0 by plugging in 0 or by plugging in any negative. So for example, like if I tried to evaluate this function at negative 4, it would be log base 2 of 0. That does not exist. I'm sorry, why did I write not equals there? That equals no solution. Because, remember, when you're evaluating a logarithm, the base is 2. So you are looking for a power that you would put on 2 to give you back 0. But there is no such power, because 2 to a positive number is going to be a positive number. 2 to a negative power, that's still going to be a positive number. And 2 to the 0 power is going to be 1. So there's no power that you could put on 2 to get back 0. And furthermore, there's no power that you could put on 2 to give you a negative answer. So the way that you handle these, similar to square root functions, is you just take that inside of the logarithm, but you're just going to solve for when it's less than 0. So in this case, solve for when it's greater than 0. You're only allowed to plug in positives. So in this case, x is going to be greater than negative 4. So that's my domain. Any x value greater than negative 4 will produce a real output here. Notice I tried plugging in negative 4. That didn't work. That was no solution. So I'm going to write my domain in interval notation here. Domain is negative 4 to infinity. Notice the parenthesis on that negative 4 because negative 4 is not within the domain. I tried plugging in negative 4, that didn't work. If I plugged in anything less than negative 4, that would give me a no solution as well. So it's anything that has to be strictly greater than negative 4. Any x value. Excellent. So now I could come up with, for my last example here, I could come up with something really fancy that incorporates kind of multiple ideas that I've been discussing. So how about this f of x? How about we'll say f of x is root x plus 5 over x squared minus 4. Now coming up with the domain of this function is going to require two techniques. I've got to worry about the square root in the numerator. I can't have what's under the square root sign being negative. And I cannot have a 0 in the denominator. So there's kind of a couple of things to keep track of here. So I'm going to take this, first thing I'm going to do, factor the denominator. So I get x minus 2 times x plus 2. So I see right away, from looking at the denominator, I can't have that denominator being 0. So I cannot plug in 2 for x or negative 2 for x. So those two values are out of the domain. 2 and negative 2 are no good. Now in the numerator, I'll set what's under the square root greater than or equal to 0. Solve that out. X is going to be greater than or equal to negative 5. Now I have to incorporate all three of these ideas into my domain. X has got to be bigger than or equal to negative 5, but it can't be 2 and it can't be negative 2. So here's my domain. Negative 5 is the smallest number I can plug in, so negative 5 up until negative 2. Parenthesis on that negative 2 because I'm not allowed to plug in negative 2. Then I could go negative 2 up to 2. Again, parenthesis on the 2 because I'm not allowed to plug in 2. But now I can plug in anything bigger than negative 5 as long as it's not 2 and negative 2. So I can also plug in everything from 2 up until as big as I want, which is probably 2 times infinity. So notice I found the domain of that function. That's a pretty complicated function. Using some of the techniques that I outlined above, I just needed to use multiple of those techniques in the same problem. So to recap, the 3 types of domains you're going to want to be able to find quickly without a calculator using strictly algebra: square roots, rational functions, and logarithms. So I've outlined these 3, so hopefully that helps you with finding the domain algebraically.